Good morning, everyone, and welcome back to day 2 of the Vismay Vigyana YouTube webinar series organized by CSIR 4th Paradigm Institute, Bengaluru, under the Jigyasa Outreach Program. Following yesterday's fascinating session on the formation and initiation of lightning, today we continue our journey into the electrifying world of atmospheric phenomena with a focus on how we track and understand lightning globally and regionally. It is once again our pleasure to welcome back Dr. Konatham Prasanna, scientist at CSIR4PI, who will be presenting on the distribution of lightning across the world and within India, highlighting regions most affected and seasonal trends, type of lightning detection sensors, both ground-based and space-based, modern tools and technologies used for detecting, monitoring and predicting lightning events in real time. With her extensive experience in atmospheric sciences and lightning research, Dr. Prasanna will help us understand how data, sensors, and scientific advancements are being used to mitigate lightning-related risks and improve early warning systems. So, let's get started with today's session. Over to you, Dr. Prasanna.
Thank you, Ms. Reena. Good morning and welcome back to the second part of webinar series on lightning. In the first session, we have uncovered the science behind thunderstorm cloud formation, initiation, charge initiation, and lightning born. And we also explored different types of lightning, its effects, and what are the safety measures. And in today's session, we will cover the distribution of lightning around the world and across India. We also explore different types of lightning detection sensors and the modern tools and techniques used to predict lightning. So, by the end of this session, you will understand how lightning risk is assessed and managed by using advanced technology, and why this matters for everything from weather forecasting to disaster management. So, without further delay, let's begin our today's session. So let's take a look at this global lightning map. You will notice that lightning does not strike the earth evenly. Certain parts of the world are more prone to lightning than others due to their unique geography and climate. Places like the Congo Basin in Central Africa, northwestern South America, the Himalayan foothills, Florida in the United States, the Pampas of Argentina and Indonesia are all known as global lightning hotspots. So, what do these places have in common? The first one is they all experience intense surface heating and also high humidity, which creates strong upward motion in the atmosphere. These are very much essential for thunderstorm clouds to grow. And the second one is in many of these places, different air masses crash. So, when warm air mass crash with the cold air mass, warm air masses tend to rise because of its lower density. This also further initiates the development of a thunderstorm. And the third reason is some of these areas are near mountains or hilly regions, which causes something called orographic lifting, where air is pushed upward by the terrain surface. This helps clouds to grow taller and powerful. So the combination of heat, moisture, the convergence of air masses and terrain that makes these regions more lightning activity regions. Now that we have seen the global lightning hotspot regions, let's zoom in on India. In our country too, some regions experience more lightning activity than others. Let's take a look at where and why. First, the northeastern states, Bihar, Jharkhand, Odisha, Sikkim and West Bengal are highly lightning prone because of warm moist air coming from the Bay of Bengal rises due to surface heating. So, especially in the pre-monsoon and post-monsoon seasons, this rising air helps in the development of towering thunderstorm clouds, which often produce lightning. Then we have Rajouri region in Jammu Kashmir and places like East Khasi Hills and Sikkim. These are hilly regions. So here orographic lifting comes into picture when moist air hits the uh, mountains is forced to rise. As it rises, it cools and helps in the generation of thunderstorm clouds. That's why we see more lightning activity here too. Now let's head south to Kottayam in Kerala. Even though it's not mountainous like the northeast, it sees frequent lightning because of the perfect combination of surface heating and the high moisture content and the influence of western ghats. All these create tall, powerful storm clouds that are leading to the more lightning activity. So where it's because of rising warm air, orographic uplift, or a combination of heat and moisture, each of these regions has the perfect combination for the thunderstorm development. Now, let's talk about how we actually detect these lightning strikes. There are three main types of lightning detection sensors used today. Each plays a unique role in helping us monitor and predict lightning activity. First, we have ground based sensors. These are installed on land and are excellent at detecting cloud to ground lightning, especially over land. They provide real time data and help in issuing lightning alerts. Then there are airborne sensors which are mounted on aircrafts or drones. They can actually detect cloud to ground lightning only over both land and ocean, but they work only in the areas and times where the aircraft is flying. So their coverage is very limited. Lastly, we have space based sensors like geostationary lightning mapper on satellites. They can detect all types of lightning including cloud to cloud and provide a global coverage day and night. So satellites can provide the global view on lightning activity 24 by 7. Now let's talk about something even more important. How can we know in advance that lightning is about to strike in some time? Let's look at how technology and tools helps us stay safe. So let's talk first about field observations and ground sensors. These are tools placed on the ground to help us monitor the conditions that can lead to the formation of lightning. On the ground, we have local weather stations, electric field monitors, and atmospheric sensors. These are very much helpful to measure some really important parameters like wind speed, humidity, and the strength of the electric field near the surface of the earth. Where why these measurements important for lightning prediction? Well, when these atmospheric conditions change a little bit, it can mean that lightning might happen in some time, and that's where real time data comes handy. It helps scientists to predict lightning. This is essentially important in early warnings in rural and for rural and remote areas where early warnings can really save lives. And the second one is satellites and radar observations. Satellites give us bird's eye view of the earth from space. So they can take real time images that can help track the growth and intensity and movement of the thunderstorm clouds. On the other hand, radar works by sending radio waves and measures how they bounce back from rain, hail, or cloud particles. This tells us how intense the storm is and how tall and structured the clouds are and how much rain is falling and where it is moving. Together, satellites and radars help us see when a storm is getting stronger and more organized, and that's often a sign that lightning is likely to occur. These tools are critical for giving early warnings. The next one is lightning location networks or lightning detection networks. We also have ground based lightning detection networks. These are special sensors placed across different regions of the country that detect actual lightning strikes as they happen. So they can measure the exact location, intensity, and the timing of each lightning bolt in real time. This information is incredibly valuable. It helps meteorologists issue immediate warnings, and also improve short term forecasting, especially during fast moving storms. Basically ground sensors are individual instruments placed on the earth's surface. These sensors helps us measure local atmospheric conditions like temperature, humidity, wind speed, and electric field strength. They help us detect when conditions are favorable for lightning even before it happens. So they are all about predicting potential lightning activity. Whereas on the other hand, the lightning location network is a coordinated network of specialized sensors designed to detect actual lightning strikes. These sensors capture the electromagnetic signals emitted by lightning flashes. By combining data from multiple sensors and locations, the LLN can pinpoint the exact location, time, intensity, even the type of lightning strike. This helps us track or detect lightning activity. So basically, ground sensors are used to predict lightning before it happens, while LLNs are used to track the lightning strike, what already happened. And the next one is weather models. These are computer simulations of the atmosphere. These high resolution models can predict can analyze a variety of important weather parameters like temperature, wind patterns, humidity, and atmospheric pressure to simulate how thunderstorms will form, evolve, and grow and move over a period of time. By running these simulations, meteorologists can predict the zones where thunderstorms and lightning is likely to occur, even hours or even days before. This helps provide early warnings and better disaster mitigation. Weather research and forecasting (WRF) model is one of the widely used model for weather forecasting. It is used both in research and operational forecast, enabling scientists to make more accurate prediction about thunderstorm and lightning. Now let's look at how artificial intelligence and machine learning are helping us in the prediction of lightning. These are advanced computer programs or algorithms that learn from historical weather data like satellite images, cloud top temperatures, humidity, and radar outputs. These models are powerful because they can recognize the complex patterns in the atmosphere parameters that are often too subtle or even complicated for humans to observe. Based on what they have learned, these models give us probabilistic forecast, which means it is going to lightning in the next 30 minutes. So it based on the probability. So it will predict 80%. There is an 80% of charge for the formation of lightning, something like that. So this is especially useful for real time lightning nowcasting, which helps keeps urban population and outdoor people and aviation safe. And the last one is mobile based lightning alert system. Once lightning activity is predicted using satellite radar or ground based data, early warnings are quickly sent to the public through mobile applications. So in India, we have a very good tool like Damini Lightning Alert app, developed by Indian Institute of Tropical Meteorology, Pune, with the support of MOES. This app sends location specific early warnings to users whenever lightning is expected nearby. So it uses real time data from IMD's network, nationwide lightning location network. And if lightning is expected to occur within 20 to 40 kilometers of their location, of someone's location, the app will send a notification to the person. So this gives you some time to take some safety precautions and safe shelter in order to save ourselves. So one of the key feature of this app is it can provide a warning up to 40 minutes in advance, which really help by giving enough time to reach a safe location and save lives, especially in lightning prone regions. In this session, we explored the global and Indian lightning hotspots, also understand why some regions are more lightning prone than others, and also got introduced to various sensors we use to detect and monitor lightning on the ground, in the air, and even from space. So we also saw how real-time data, weather forecasting and machine learning models are helping us in predicting lightning more accurately. Understanding where lightning strikes and how we detect it is now not just about science. It's all saving lives and preparing communities. Let's remember, by staying alert using tools like Damini app and following safety tips, we can all stay safer during thunderstorm and lightning. Thank you for being a part of this series, and stay safe, stay informed, and let's work together to save lives.
Thank you, Dr. Prasanna, for another enlightening session. Today's presentation gave us a comprehensive overview of how lightning is not just a natural wonder, but also a measurable and predictable phenomenon with the help of modern science and technology. Your insights on the global and Indian lightning distribution, the types of detection sensors, and the modern tools used for lightning tracking and early warning systems have truly expanded our understanding of how science is helping protect lives and infrastructure. On behalf of CSIR4PI and the Jigyasa team, we extend our heartfelt thanks for your engaging and informative sessions over the past 2 days. A special thanks to our viewers for your participation. The recordings of both the sessions will remain available on the CSIR4PI YouTube channel, so feel free to revisit and share them with friends and colleagues who are curious about the science behind lightning. Let's continue to nurture our curiosity and appreciation for the wonders of science. Don't forget to subscribe to our channel and stay tuned for future webinars in the Vismaya Vigyana series. Thank you once again and have a safe and inspiring day ahead. Thank you.